Ever wondered if time and space could be absolute? Newtonian relativity gives us a perspective on this. It's a scientific concept that hails from the brilliant mind of Sir Isaac Newton, one of the greatest scientists who ever lived. Newtonian relativity, or classical relativity as it's sometimes known, posits that time and space are absolute entities. They do not flex or warp around objects. They are fixed, unchanging. In this grand theater of the universe, according to Newton, space is like an endless stage, stretching out in all directions, unaffected by what happens within it. Time, on the other hand, is like a ceaselessly ticking clock, measuring out moments with unerring precision, irrespective of where you are or how fast you're moving. Newton's view of the universe is like a grand, unchanging stage where events unfold. It's a perspective that has shaped our understanding of the cosmos for centuries. So, how does Newtonian relativity work exactly? Let's break it down. This theory, at its core, is a bit like having a crystal ball. According to Newtonian relativity, if we know the state of the universe at one point in time, we can predict its state at any other time. It's based on the assumption that the laws of physics are the same everywhere and at every moment. So if you're whizzing around the universe at any speed or direction, the physical laws still apply in the same way. This is where it fundamentally differs from Einstein's theory of relativity. Einstein brought space and time together into a four-dimensional fabric known as space-time, and this fabric is dynamic. It can warp and ripple in response to the presence of mass and energy. In Einstein's universe, the dance of the cosmos is not just performed by objects moving in space, but also by the space itself. However, in the Newtonian worldview, space and time are more like an arena. They provide the stage upon which the cosmic ballet is performed, but they themselves do not participate. They remain uniform, unchanging, and absolute. So in essence, Newtonian relativity views the universe as a grand clockwork mechanism, where if we know the initial conditions and the rules, we can predict the future and retrodict the past. In the Newtonian worldview, space and time provide the arena, but they don't join the dance. Now you might be thinking, what's the big deal about Newtonian relativity? Well, let's dive right into it. Newtonian relativity, also known as Galilean relativity, has had a monumental impact on the history of physics. Its principles have been the foundation upon which classical mechanics was built. This branch of physics, in turn, describes the motion of macroscopic objects, everything from a falling apple to the orbits of planets. It's the reason why we can predict the path of a football in mid-flight or calculate the forces acting on a bridge. Despite being centuries old, Newtonian relativity isn't some dusty relic of the past. It's still incredibly relevant today, especially in many areas of physics and engineering. Sure, Einstein's theory of relativity has superseded it in some aspects, particularly when dealing with high speeds or large gravitational fields. But for most everyday situations, Newton's laws hold up just fine. In fact, many of the technological marvels we enjoy today, from skyscrapers to space travel, owe their existence to the principles outlined by Newton. His work has shaped our understanding of the physical world and continues to guide us in our exploration of the universe. So, while Newtonian relativity may not have the final say in our understanding of the universe, it still holds a key place in the story of physics.